Hey, um, I'm Ryan. My name is Ryan, and I don't have a coherent topic, but I just wanted to mess around a little bit more with Scratch and with C, and yeah, just kind of talk more about the same thing over and over again, because that's fun. Um, the first thing I wanted to do is to show you guys the export feature of TurboWarp. And I think this is really cool because when you make a Scratch project, or at least for me, the progression from that was to build something that was like a real application. And with this export, you can do that just from scratch, so you don't have to learn anything else. And when I say real application, I mean it's something that you have it in your file explorer, you click on it, and boom, we're in. And it's like, there's no scratch visible. So yeah, there's this package project. I was looking for this. You can configure your settings here, the TurboWarp settings, and then you can choose between native applications on Windows, Mac, and Linux, as well as this HTML file, which this will just run in the browser. So I've made one of these before for my font editor, and then I just made this one, which generates a zip file with a bunch of libraries and then exe, which is your application. So it's pretty cool. I mean, it's kind of a hack, right? Like, this is Electron. Electron is a framework used to turn websites into standalone applications, and Scratch is a website. But it's kind of weird because, like, inside this website is this rendering canvas type thing, and then Electron kind of wraps a whole browser around it. So it's not very efficient, right? So in terms of like getting down to the draw calls, which I assume is using Vulkan, which is a graphics library, we're like at least a couple steps of indirection. Our binary is super big. It's got a bunch of stuff in here we're not using. And that's something that definitely for me more recently I've liked to kind of cut down on all the stuff that I'm not using. So like, how big is this? Let's see. This is like 200 megabytes. So what's the minimum amount of like dependencies we can get while achieving the effect that we want, right? For Scratch, it's like, it should be quite few, because Scratch has quite limited capabilities if you just consider this aspect of it. As a whole website, obviously it has a lot more. But in terms of what you can do with just this area, or like what that requires from your computer in terms of libraries and support, it's not that much. So I don't really have I don't have an answer to anything. I haven't recreated Scratch in C. I've made a library that kind of recreates some of the pen features, and I'm going to show you that next. So, gosh, I didn't have a clear focus for when I started this video. Okay, first I'm going to show you, real application. I wanted to build real applications. I only do Scratch. Eventually I learned Python and I learned C. And with C, you can build EXEs by compiling your source code, right? So this is the same project, but it's written in C. Let's turn on trusted mode here. So this takes pretty much the same logic and puts it into a bunch of C functions, and then I wrote a library that will do all the pen. And this project is fully pen rendered, so that I don't need to draw sprites, which I wouldn't have the capability of doing. But What's the point? The point is that we can take this and compile it. And I have a make file that does this, and a make file just runs, and I called it the Linux compile. Let's compile that for Windows. Make file will just run this in the terminal. So this is a computer terminal, if you're familiar. This is where you put commands in. I don't really know what who the audience of this is. I don't know what I'm doing. Okay, this will compile the project. We'll create some binary exe, kind of like the one that we have here, that you can just run. Because this is Windows, and exe is a binary file that you can run on Windows platforms. And so I can just run this, and we have the same application. Now it pulls up this terminal, which is annoying, and if I close the terminal, it closes. There's actually, we can find a way around this, but for now, we'll just leave that up. And yeah, it's the same application. And it's a little bit bigger. Now, one of the nice things about Electron is that it's gonna let you resize the window. So when you run it, it's really small. It's also got the green flag, which I'd like to not have because I don't want it to be obvious that this came from scratch, but I believe you can just disable it. There's a option. I don't know where the option is. Aha. Start project automatically instead of showing big green flag. And since my project doesn't have sound, it seems like will be fine. So if I make this, let's make a standalone Slate application. Okay, now it won't have the green flag. Run this, opens in the browser, boom, there it is. But anyway, with the application, we can resize this window, and you'll see we'll get these black bars, or these horizontal black bars. We can make it the right size. This, on the other hand, it's more my fault that I don't know what I'm doing, but when I resize it, it doesn't work, or it doesn't do what I'd like, and that's not what's supposed to happen. So that's unfortunate. Oh, and then it just breaks. Oh, never mind, we're back. Yeah, this could be fixed, but this is just one of the features that Electron's gonna have out of the box that you're gonna have to make yourself. That's gonna be a common theme here. Pretty much all of the basic Scratch functionality, you can kind of replicate it, and this is similar to stuff that I've done. Okay, so we made a real application. We are using C now. What was going to be my next point? Right, we're going to reduce the size of the binary. If we look at the size of this binary, so this HTML is only like a megabyte, 2 megabytes, which is pretty impressive. But of course, being an HTML file, it runs in your browser. So if we open this up, it's going to be a bunch of stuff that I don't know how this works exactly, but we're leveraging a lot of the rendering capabilities and support libraries from the browser itself. Whereas with the standalone application, we're not using any of that. We're relying on only the computer's operating system libraries and anything else that we've included. So that would be all these DLLs, FFmpeg. I don't know what these are, probably for rendering. Vulkan, shaders, some binaries. Don't know what this is. This is just the... Cool. But with the C application, you can see that it is, how big is that? A megabyte? Okay. And it's an exe. We do leverage a few libraries. Now these are just C header files that I've written. But we also have these Windows libraries, which are in here. GLAD and GLFW for the window, glad is for OpenGL, and I'm also making use of a couple others that you can see in the compiler flags. So this is glad. We've got OpenGL on Windows, some other stuff, and these you can find them in the Windows system. So the way that the compiler works is you give it a source file, you give it an output file, and then I've given it these other flags, which are libraries, except for this one. This is a macro that I set. This tells it to find libraries in here. That's -L. This tells it to load library glfw, load glad from there. We're going to load these from another location, which actually let's try to find. So this would be called this without the L.dll, and it's actually many times on my computer. I'm assuming it's the system32 one. So this is where this library lives, and I actually have a program that allows me to open these in, it's called a dependency walker, and it actually seems like this is requiring a ton of different libraries. So we're including this in our project when we compile. This is an operating system library, so it's in Windows System 32, meaning that if you have Windows, you have this. And then these are going to be similar. We'll probably find them in the very same way. And in fact, they might even be in the same directory. Yep. This is also in System32. There it is. And I'm sure this one would be too. UUID. Don't know what that's for, to be honest. I don't remember what the purpose of all these are. Actually, no. Don't know where this is. Maybe it's not a DLL. Oh, .lib static library? That's a Python library. Don't think it's that. Well, who knows? What's the purpose? What am I talking about? These are operating system libraries, so we stripped a layer back, right? Instead of running through the browser, like our HTML file does, we run through an operating system, which the browser runs on top of. So if we think about our map, let's actually try to map this out. So Scratch, the website. Wow, this is great. Oh, don't like that H. Scratch is a website. Oh, I should make this bigger. And it runs inside a browser. So if you downloaded the Scratch website, right, you don't need the internet for it to run. Like you obviously need the internet to connect to Scratch's MIT server or whatever, domain. But if you downloaded all the contents, all the files, all the scripts, the code and assets, you could run Scratch in a browser offline, and then a browser runs on an operating system. So the browser is a native application of the operating system, and then an operating system will run on hardware. So each one of these layers, oh gosh, I don't know why I'm using Paint for this. I should be using the Scratch vector editor. Actually, let's do that. All right, new costume. Now this is what it's all about. Okay. Red. Make this transparent, please. That's a terrible color. These are all terrible colors. Let's just make it all white. One second, sorry. This is... Also, please clear the screen. Okay. So browser, operating system, hardware. Why is my thing transparent? Okay, we're so back. So what happens when you take Scratch and make it an exe, like the thing that this one? What's happening there? Well, we're using Electron, and Electron is an application that it'll take Scratch as the website, and it will take the browser. So this section is Electron. So I'll put it in a box that says Electron. Oh gosh. Why must it be so annoying? So what does this mean? Is this an extra layer? I would say, okay, well, let's replace, actually, I was like, I thought, yeah, we're not going to run Scratch in the browser anymore because Electron is the browser now. So this is what we've actually done. Let's get rid of that. So Electron is replacing the browser in this case, right? So we're running Electron right on the operating system. And really, we put it all into one binary. So our application doesn't live here anymore. No. Previously, our Scratch application was in Scratch, right? We wrote it in Scratch. So we can even add this extra box here that is our application. I'll just call it app. But what we have here is our app running on the OS because it's a binary, in the sense that I can take this exe and I assume that I could put it anywhere. No, because it needs dynamic libraries when it runs. Okay. So this exe requires these libraries to be in the same directory as it, or in the path, probably. So actually there might be, okay, not much in there. So our app is technically running on the OS here, but it requires Electron to kind of be there. And when I say Electron, I mean all of this stuff, the rest of the stuff here, including what created this binary. Typically a binary can kind of just run anywhere. Like if you have an exe, you can put it in any directory, but this exe in specific requires some of these libraries to load when it runs, I think. At least I think that's what's happening. So our app is running on the OS, but it kind of still needs Electron, and Electron has Scratch inside it. So our app was created by a process of pulling it out of here and putting it over here, and replacing the browser with Electron. because we can uninstall the browser and we'll still be able to run this exe. Okay, that's Electron, or that's the application. This is the Scratch website. So what, and then also this is also if you have an HTML file, what does that look like? Well, that gets rid of, let's put this back to a browser. This is HTML file. That gets rid of Scratch. You don't need Scratch anymore. Our app will run directly in the browser. So we can just put our app right there. Okay, this is an HTML file from TurboWarp's packaging. This is Electron app from TurboWarp's packaging. This is the Scratch website. And now let's do Python. I wrote the same program in Python before I wrote it in C. Each one of them losing versions as I developed. So let's actually see. Here it is. So to run things in Python, you got to use Python and then logically.py. You can't just click on it, and here it is. And it's got a really bad color scheme for the dark theme because this is an old version of the application. I updated the Scratch version after making this, and then I updated the C version for a long time after, and just left the Scratch version. Anyway, that's not important. Important thing is we have a Python application of the same thing. How does this work? Well, we have this Python file where this is where the code is, but we can't just run it on the operating system. We need not Scratch, but we do need Python. And specifically, we need the interpreter. But I'm just going to call it Python because that's going to be too long. And I'm just going to call this the Python app instead of just app. So to run the Python version of this program, we need to have Python installed. And we also need to have a bunch of libraries. So I'm going to make another box here. And I'm just going to call this one I might call this one environment. Okay. So let's try to compare some of this stuff. What is Python? What does it mean for Python to run something? It's what's called an interpreter. So it's kind of like it's a program that runs on your computer, and it reads the code. It reads the code line by line, and it executes that as it reads it. So pretty simple, pretty like what you'd expect. Where am I looking? I'm looking for this. It's what you'd expect a program to do. So like you write a bunch of code, and then you imagine that something goes down and says, all right, I'm gonna execute this, do that, do that, do that, do that. And it just does it. And obviously, like when there's an if statement, it'll like, skip over this, do the for loop, do this, do this, do this. That's basically what Python does. But it can't do, it needs that program, right? That special interpreter program, which runs on your computer. And when I say it runs on your computer, I mean it's a literal binary. So this Python doesn't get turned into a binary. You can turn Python into a binary. It's not that difficult. In fact, that's how most packages work. But right now, when we just run it with Python, we are using an interpreter. And to be honest, I've never tried to turn this into a exe because I didn't know you could do it when I wrote this. And I would be curious to see how much faster it is. And then when I talk about this environment, I mean it's all the stuff that enables these imports. So I think in this case, I'm actually not using any special libraries, but oftentimes you'll see people using special libraries. Pygame's one of those, and by special I mean it doesn't come default with Python. So if you install Python, you'll get a bunch of stuff. Just like as you install a browser, it'll come with a bunch of libraries as well. The difference with the browser is that it's not often that you're gonna install more libraries for the browser. It kind of just has all of them. It's like if you install Python and it came with pandas and TensorFlow and beautiful soup and Pygame, and it came with it all, and it was just always available. It's annoying to deal with a bunch of different Python libraries because different projects require different ones, and it's very common that you'll try to run something with Python, but it won't work because you need some library. You got to pip install. You might even need a different version of Python. That's pretty common too, and that's quite annoying. That's another thing that I mean by environment. So it's the version of Python, it's the different libraries you need. It shouldn't matter your OS, but I don't actually know. I don't know too much about Python. I don't know that much about anything actually. Anyway. Okay. So if you did compile your Python, you could probably remove a couple of these layers. Get something more similar to this, except that you don't need these to stick around probably. Speaking of getting rid of dependencies, let's see what the C version uses. So with the C version, we have our C app, and really this is just a binary. I'm gonna remove this Python box, but I'm gonna keep this environment box. The main thing is that really, once you have this exe, we have a very simple diagram here that's much closer to the hardware. And that's what this binary is, this one right here. So this binary will work anywhere. Actually, no. It does rely on a couple of files here that it needs to load, font file, and these two files. So if I just sent this exe to someone else or to another computer that has Windows, and you tried to run it, like if I pulled this out of here and tried to run it, it wouldn't work. But it's very close to working. Where did it go? Actually, it did work, but it couldn't load some textures. I forgot that this thing has textures. And the ribbon didn't load. So it's mostly still working. But if I turn on textures, they all go away because there is no textures. And that is a little bit broken. Let's undo that. So what's the difference between needing some files like this and needing libraries? Really not much. When a program gets, this is like, we're getting into real program territory. Now, I don't really know how things get installed. I don't know how installers work. I've never used them. But when a program gets installed on your computer, and let's look at an example of that. Let's go to my program files. What's a good program? Let's look at Scratch. This might be a bad example, but no, maybe not. We have this application, this exe for Scratch, and if you run it, you're going to get the Scratch 2 editor. There it is. And it's an exe. So it's a native application that runs on the hardware. But it does have a bunch of files that it relies on, right? These are images or icons. These are language files. Actually, I don't know what these are. I think these are language files. There's some SVGs. That's nothing. I guess there's just more images. There's a Git modules. This is a SSH. I'm actually curious what this is. Never looked at this. Okay, not what I was expecting. interesting. And it's got all these other files that it needs. If I take this exe out of this area and try to run it, it's not going to work. I think the main reason it didn't work is because Flash wasn't around. Now I shouldn't have done that because now I can't get back. Okay. I don't really know where Flash... Oh, never mind. There it is. Or something. Some drivers. I don't know what's going on. There's a driver here. Interesting. This requires some 32-bit Windows drivers in this assumedly Flash driver. I actually don't know how this stuff works. It's like Adobe Air, which is, I guess that's Flash. But what's the point of saying all this? This is what happens when an application gets installed. It puts an exe usually in here, in this program files in some folder. It gives it a bunch of extra files. So it's really kind of like if we put in, we took this, we took all of these, and we just put it in here. We could do that, and it would still work. And then we could put a shortcut to it in here. I think I don't have a shortcut to anything. And then you could literally search, we could put a shortcut in the start menus, is what I mean. So like wherever this is, open this file location. Programs. I have a Scratch 2 shortcut. I could already put a shortcut to this. So all I need to do is make a shortcut. It doesn't even have to be in the program files, and I need to administrator that. So now, there it is. It's called a stupid thing, but if I click on it, boom. So we're getting like surprisingly close to it looking very real. It seems very professional almost at this point, and I like that. But we are still in Scratch, so yeah. So and then here's the other thing about the Electron Scratch thing. We're kind of going to be limited to things that Scratch can do. If we take a Scratch project and make it a real-life application, it can look very, very professional. It can appear in the start menu. You can have an installation where it puts it into the program files. I don't actually know how to do the installation thing. Like usually, when you download a program, and if you're on Windows, this is what normally happens. You either get an MSI, Microsoft installation file, which is a binary, or you get an exe, also a binary. I actually don't know if the MSI is a binary. Don't know how the MSI works. Those are installers. And what they'll do is they're just, and I have a ton of them. Let's actually look at them. Let's see what kind of stuff I've been installing. Pivot. I installed Pivot recently. I had in Valorant. That's terrible. Don't look at that one. Bunch of programs that I've installed, and all these installers will do is populate in your program files the files that it needs. I don't know where it gets them. Probably from the internet or from a server. Actually, maybe not. Some of them maybe already have everything. Like this one, which is like a gigabyte large thing. But maybe others are going to use libraries from your system or download files from the internet, or I don't actually know. It's kind of yeah, I should learn more about it. But it'll make this here, and it'll put a shortcut in your start, and then you've installed the program. And that's all it is. It's just a couple of binaries, shortcut, files, and then you have a real application. So yeah, you can take your Scratch, you can do the same thing. This always happens whenever I do this. Oh God. Okay. Whatever. and then you can have your Scratch app be an application on the computer. The only problem is that you're still going to be limited by what Scratch can do. So there might be things that you want to do, your application, that can't be done on Scratch. And that seems like you can do anything, but I mean stuff like talking to other devices, accessing websites, doing kind of these external I/O operations, which Scratch deliberately is not built to do. So in Python, there are libraries that allow you to go to websites and download content, or you could open up a COM port and send data over USB or over UART, I guess. And all these kind of external I/O operations that a Scratch program, even if it's installed on your computer in this way, will never be able to do. TCP/IP, all kinds of stuff. So you're going to be limited by that if you want to use Scratch as an application builder. And then the other thing is that it's just not that great. It's not built for that. We are able to make it work. You can take what's in here and put it in here, or I guess in the other one. But that's not what Scratch was built to do. And that's fine. Scratch wasn't built to do many of the things that people have done with it. But yeah, you're gonna like eventually find that you're gonna probably want a kind of support that Scratch doesn't provide. Yeah, even just writing to files. That's a very simple but also external I/O operation. Scratch will never be able to do it. Certain key detects for key presses. Like famously, you can't detect the backspace key or the shift key or the escape and a bunch of others. I know there were ways around it, but they were never super reliable. They didn't always work. I remember doing a lot of stuff with that. Or accessing native libraries on your operating system, doing anything with the operating system. We're kind of too many layers away with this. Electron can do these kinds of things. I imagine JavaScript can. You have Node.js, runs on your computer. But with Scratch, it's another box inside Electron that can't really stick its hands out. So you're going to run into those kinds of limitations, which Python, if you wrote it in Python, all of these, you can reach your hands into any of these, right? C, even easier. It's kind of built to do that. Oh yeah, I was gonna show you guys one of the projects I made that is fully a one binary application. And I think this is really cool. So you know how my logic gates, not this one. So this one. This one's a minimal dependency, not minimal, but it's a low dependency binary. It has a few files in here that it needs, that it loads on startup, but they're not very big, and that does prevent it from being just a single binary. And this other stuff is just for making it, right? Like if you just want to run it, all you have to do is have this one file and a few others. But because there's such a small amount, and the other thing is like these other libraries, these ones, and the other ones I showed you, the ones that get compiled in, they get statically compiled in. So they become part of this. So if we actually open this with a different application, am I allowed to do that? I actually don't know if this will work. I'm not sure if this is compatible in the way I think it is. Let's change this to a DLL and try to open it. Oh yeah, okay. So you can see that we actually have these, and these DLLs mean that you need these. If I get rid of one of them, this program won't run anymore, and I need to also rename it to be.exe again. So compare that to the Scratch one. Let's rename this. Okay, yeah. Wow, this needs a bunch of like old. So the syswow64 directory is I think Windows 32-bit libraries. I would have expected to see. Oh yeah, ffmpeg. Okay, I thought that you would need all of these. It doesn't look like you do. Just ffmpeg, and it's an absolute path as well, which is weird. Maybe it's relative, actually. It probably is. It's just that I just happen to have this in this one directory. Okay, so this is what it needs, right? There's a bunch of them, and these need to exist if you want to run this. If I delete one of these, if I go to syswow32, or if I go to system32 and I delete one of these files and I try to run my program, it won't work, or it probably won't work. Actually, it definitely won't work. So this is what it needs to exist. What was the point of me saying this? Okay. These are all operating system libraries, and in this case, they're all operating system except for this one. So that's why you need the ffmpeg. That's why you need to be in here. Technically, you just need these two. With this, you don't need any of that. So I could theoretically move this anywhere, but you do need those files. It loads those files because it's part of the code here where it loads in files from a relative path. The icon for this thing, see there's an icon there, and up here the font file for the text, and the texture files for all of this, and a couple other things too. So, but because it doesn't need any actual libraries that need to be loaded in, it is possible to just generate those files. So this is what I've done. In another application I made on my last semester of university for a research thing, we've got this release here, and typically, well, I can't say typically with any degree of certainty, but sometimes they'll put an installer here. Oftentimes they'll just put a bunch of binaries. I just need one binary, and the way that this works is, let's download this. Let's put it just here. This is a one binary program. This is the only thing you need. Now it will generate files. That's the way it works, just because I'm lazy. If I run this and the files don't exist already, it'll generate them. Oh, and Windows is mad at me. I know this is safe. And it needs some hardware, so I'm gonna run it with a flag. Okay. But you'll notice that even before I did that, it generated these files. These are the two files it needs. That's a font file. That's the configuration for this thing. Everything else is just inside the binary, and theoretically these could be too. That's how it works. The code is actually insane for doing that. I wouldn't recommend doing that. It's not in here, is it? Autogen font and ribbon files. I took the files, the literal binary of the file, as in like every byte, and put it in an array. And technically that should be enough, and I wouldn't have to actually make the file, but because of my because I didn't want to change all my code. I just have it generate the file and then read the file again. So if the file's not there, it'll just write this to it, and this is the font file, and then I have another one for the other file, which is a lot smaller, so I won't be able to find it. So it'll regenerate the files, and then it will run just fine. Because it doesn't need those extra binaries anywhere, those libraries, and it just needs a few files, it can make those wherever it is. And in theory, it wouldn't have to do that. I like this idea. I think this is very convenient for a user, because I remember being really confused when I started diving into trying to make quote unquote real programs, and I kept not understanding when I went to GitHub how do you GitHub really confused me, because I'd go to GitHub and I'd find a repository for something that I wanted. Well, I don't have an example. Let's just, honestly, if we click on one of the first, let's do this. So if I wanted to get this extension, which is what, apparently this is an extension for VS Code, I don't know how. Now there might be installation. Okay, this requires something. A lot of the time there would be installation instructions, but I didn't really understand, and I just there's so many files, and none of them are binaries. There's no releases for this. I never really knew how to actually run things. I really liked the simplicity of being able to clone or just download a bunch of files from GitHub or anywhere really, and then having an exe there that I can just run. And I still feel like I still think like that. I don't really get this. I probably can figure out what a lot of these do, but it's I don't really understand what the purpose of having so many files is. And it just seems like they just go on forever. Look how many folders there are. And why do this? Oh my gosh. And this is a TypeScript, and it's so small. And it just was it makes it so unwieldy to have and to use and to figure out what you even need to do. I really like the simplicity of just having one binary. You download it, you run it, and it'll just work. And it's small. This is not even a megabyte large, this whole application. It's lightweight. Unfortunately, we need hardware access for it to work properly, but we can have this demo version if you run it with that flag. There should be an option to just click a button, but I kind of got rushed at the end. Yeah, I should have a button right here, because right now it'll just try to connect on a TCP port to a device that I don't have right now, because it was part of the research lab, and then it'll eventually just give up and tell you that it's not connected. But all of this functionality, all of these things, this whole font, this whole rendering, it's all statically linked, so you can I guess there's a couple of dynamic runtime libraries. We can do the same thing with this thing. It's probably going to look really similar. It's made with the same technologies. Yeah, actually we need a few more libraries here, like the WinSock library and this one as well. And those are, and then I guess a couple of these, and those are for TCP/IP, which is what this application will use to talk to the external device. But yeah, I just under a megabyte binary with all of this kind of functionality, all of these different things you can do. To me, that's, oh god, don't worry about all the things I never finished and bugs that I never fixed. That's great. This is just like really, it gives me like a lot of peace of mind when I'm building applications to know that they're very simple to run and to use. I like that kind of simplicity. I like putting everything in one file. I don't know why. Well, I do know why. I just like, I like having everything just right there, being able to see it. It does make it sometimes a little bit annoying to edit, but I don't think it's more annoying than flipping through a bunch of files where you don't know what you're looking for. Yeah, I guess I just really like the small and simple, which is why I decided to go with C. And I'm still used to this whole Scratch stuff, so this is much of this, what you see here is just like a Scratch application. It's a very complex Scratch application, but you could do a lot of this in Scratch. The only thing you couldn't do is the whole TCP/IP thing. That's something I had to do with like new technology. I had to write code for that. Well, I had to write the code for everything, but like it's not something that I could leverage any Scratch knowledge from. But all this other stuff is like the coordinate systems is, you know, it's actually 640 by 180 because it's a 16 by 9 instead of a 3 by 4 or 4 by 3. It's a combination of a bunch of stuff I built up over the years, but at its core, it is I just hit the refresh button. It is Scratch. It's built on a Scratch foundation, but not in the way that like this one is. Sorry. It's just like libraries in C that try to emulate the behavior of the Scratch pen, and then I just build everything on top. So what am I trying to say? I don't know. I don't know why I made this video, but I will just say, like, yeah, you've got the start of application building with Scratch. Like, it doesn't do it all, but you can get pretty close with stuff like this. And with just a little bit of work, you can turn it into stuff like this. Well, it's a lot of work if you want to rewrite it in a whole new language. But we can go from writing Scratch programs to writing stuff that looks quite professional, but really at its core is still the same. It's still just the same kind of thing. And that's another thing with it's when it comes to the philosophy of programming. For me, it's always been about building a whole system, right? Even when I was writing stuff in Scratch, I would write utilities. And the idea with the utilities, which just never really happened, but if we go to like a lot of the stuff that I made, oops. This one will just make hashes. This one generates permutations. All of these like file things, because I thought I was being really professional, or like I was like, oh, files, like that's computery. These are all utilities. All of these programs, they're kind of like libraries, and libraries in Scratch don't tend to be very widespread because it's kind of hard to import them. One of the ones that I was mentioning before is like the pen text engine. That's an example of a very successful library because it's used in a lot of different projects. And I really liked the idea of building a bunch of building blocks, pieces of technology that you can then build upon. So I would integrate these kinds of things into my other projects. I'm going to make a game. I'm going to be using the different things that I've made to help build the game. In practice, this didn't really happen with Scratch. I never really did that. But in C, this has been all I've done for the past few years. every time I want to write something, and this is what all these includes are, I read it in a header file, and these are some older versions of them. So this turtle library will implement the Scratch pen. This one will render text on the screen. This one gives me textures. Well, I guess this one gives me textures. This one will interface with the file dialog, allowing me to interface with the file system. That allows me to do stuff like this and actually have this pop up. It also allows me to use the clipboard so I can copy and paste text and just text actually. That's a Linux version. This one's just the Scratch list, but in C. This one gives me the pop-up that allows me to... I don't think I have it enabled on this application, to be honest. But on the Logic Gates one, it does a little pop-up. And so all of these libraries, it's similar, except more useful than these, because it's kind of the basic building blocks just to get me back to where I was in Scratch, and some new ones that I wasn't able to do before. And you just build it up. You just keep building these different ones until you have a whole collection, a whole system of your own handwritten, like, I don't know, like you have a whole, you have everything you need, like, right? Whenever you need something new, you can write a library for it, and then you have that forever. You can always use it again. If you end up using a bunch of different technologies, like different languages for different projects, or different packages or frameworks and stuff, like every project you have is a different framework or a different language, then you're not going to be able to make use of this kind of system building, because you'll write a program and maybe you'll write a bunch of parts, combine it into a whole, but then if your next project's in a completely different language with a completely different system, all of that work is kind of only being used for that one project, and it seemed to me like a waste, right? Like, that's a lot of work and that's a lot of stuff that you implemented, but you won't get to use it again. Whereas for me, I'd like to be able to use it again forever. If I write a sorting algorithm, I don't want to have to write it again. If I write a algorithm for rendering text, or for calculating, I don't know, any kind of complicated probability calculation or graphics and stuff like that, I want to be able to use it whenever I need to. If I have another project that I was like, oh, I need to sort something, I can sort it. I need to write text, that happens all the time, I can do it. I need to use TCP, I made a library for it, so I have that now. I have one for COM ports. I think it's bundled into here now. And now I can do that for forevermore, and they shouldn't break. That's the other thing. I don't want them to break. So I write them all in C because I feel like you can do anything in C. It seems like you can do pretty much anything. Unlike Scratch, right? Scratch is limited. It's got that scope problem. But C is global. It runs on almost anything. It can interface with the operating system. There aren't any limits on what it can do. And it's really fast and powerful. And so when I write on my libraries with it, they seemingly can be used in a lot of different places. Even when I'm forced to write stuff in Python, I can still call C functions using C types. And most things I write are going to be using C. So that's why I'm writing on my new applications and keep doing this kind of stuff with the same framework that I just keep building. And I just improve upon as I need to. And I really like that, because it just feels like the work, like my life's work has a purpose and it builds to something. It doesn't just go up and down. And the things that I made from the past, well, it's like the time wasn't wasted. Um, so I guess a lot of this video is just trying to justify how my scratch time wasn't wasted either. Even though the code itself isn't directly being used anymore. Like in some way that there is something still being used. I still took some pieces. I only had to learn things once. Yeah, I think that's everything. It's been an hour, so I will catch you guys later. There's no guys that I'm talking to. I'm just gonna end the video.